Hello. Okay. Hello. 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 Not sure if the online students can hear me. Yeah, I think it's better now. Okay. Okay, guys. So let's start. I think, guys, for you.
Yeah, I think it was the middle where we talked today.
No. I think I figured out. It's the same thing. I think I figured out something I'm gonna say in the beginning. So last time I explained, okay, I explained interrupts, and I told you I explained two sources of interrupts: external interrupts and also system tech. This one, which can generate periodic interrupts. Okay. As I told you last time as well, we have. Let me go back to here. Yeah, we have here. If you look here. For interrupts here, we have what we call system interrupts. Okay, so this one's for the system itself, for the processor itself, and we have what we call peripheral interrupts. So this mainly for the user, and this part mainly for the core system. Okay, so and I told you system tech, what we programmed last time, this is a part of the system. Is that okay? I'm gonna teach another timer that can do the same thing like this one, but here it's under peripheral. Is that okay? So we have two timers. We have two different timers. The one I already explained last time, and this is part of the system. Okay, I'm gonna explain another timer is here, but this is like a peripheral. Okay, so because this one is a part of the system, as I told you last time, this one is also used by your project somehow. So your project is using this one. That's why last time I told you, I told you you have to comment it here, okay? Because what happens, I told you, the project itself is using this one, as you see here, okay? Somehow. However, I found, it seems to me that's the problem you are suffering, you and the other students, and I think most of you are going to have this problem when you do the project. I found that when we commented this way and we created another handler in our main program, when we did that the project itself in its operation is going to use this one, as you see here. Okay, so and this created a problem when you used the ports and other things. So what I want to tell you, especially for this one, for system tech, only for this one, especially for this one, try to uncomment this one, and you can write your code here so that you can still run this one. And this function is needed by your project. It is needed by the ports and other things. You got what I'm saying, guys? Again, we are gonna do this only for this one, for system tech, because this is a system interrupt. So it's used by the system. Or you got what I'm saying? So it seems to me when we commented it here, so this one is not going to be used, and this created trouble because the project itself is using this one. The way the project was built is that they are going to use it. Okay, we didn't have a trouble, I think, in the last project, but it interfered when I commented this way. So try to uncomment it and see if I think everything will be okay. Anyway, so what I'm saying, guys, is that for this one, uncomment this one, and then you can write your code here. The code you have to write for the project, just write it here. Yes.
I don't. I'll have to go back and check. For our previous lab with LCD, when you had told us about that, last lab. During her lecture, during last lab, I took the HLL, in Tick, and I took that copy and pasted to the main.
That's okay, you can do it.
And ran that, so I thought we had that brought to the. But I will check that.
Yeah.
But will that work as well?
Again, the problem with this interrupt, this is a system interrupt. So I can say it's not a peripheral interrupt. So your project needs it, even if you don't use it. Because I say so, it's, you can see here the project created it, and the project is gonna call this one. Is that okay? So my advice to you, okay, number one, try to uncomment this one. Number two, write your code here so that you can use it. Also, the project can use it. So just write your code here and see what's gonna happen. Is that okay? And I asked you to program it for 200 milliseconds, okay? Don't program it just because it's already programmed. So the project is programming it for a certain time. You can say, so just put it here and see what's gonna happen. Is that okay? Again, we have this is because this is a system interrupt. You can say, when I explain the timer, when I come to the timer, you don't need to do all of that because your project is not going to use it, right? This is going to be use. But the problem here, your project is using this one. Anyway, try to do it because it looks like, try to do it and see what's going to happen. Okay, I think you're not going to, yes. Yes, uncomment this one and just write your code here because you want to, and don't program the system tick. So don't it's already programmed in your project and already the interrupt is working. Okay, so all what you have to do, just write your code here and uncomment this one so that you can use this interrupt. Also, the project can use this interrupt. Try to do it and still if you have any trouble, let me know. Okay, sorry. Again, this is just a special case. That's what I want you to understand. This is a special case because this is system interrupt. So the project, we're not gonna have this problem with any other interrupt because any other interrupt is gonna be a user interrupt. So it's up to you. You can how you use it. However, this one because it's a system interrupt, it is used by your project here. And I think when we commented it, this create it worked well with these programs. Okay. However, when we try to use other ports and other things, it didn't work well. I think there is some kind of we did some kind of interference. Anyway, try to do what I told you, and I think everything will be okay. So last time I explained this system tech, I told you this one can be used to generate periodic interrupts. Okay. I'm going to also explain a timer. This timer also can be used to generate periodic interrupts. Is that okay? And also, I told you here, for this periodic interrupts, you should have maximum time here. We have a maximum time. We calculated this maximum time last time, and I told you, if you use internal clock, this maximum time is going to be 8 seconds. If you use external clock, it's going to be 64 seconds. Is that okay? That means you cannot have interrupted more than 8 seconds. So that means the time here, the time from here to here, it can be actually less than or equal 8. If you use this one, less than or equal 64. Is that you understand what I'm saying? Because this is a limit. This is a maximum. It cannot be more. Yes.
I'm sorry if we already went on this in previous class, but if we're going to keep the sysdig handler in that C file uncommented, should we get rid of the one on main?
Yes, because you cannot, in C language, you cannot define two functions with the same name. Okay, so you have to delete the one on main. Otherwise, the C language is gonna give you error. It's gonna give you double define, or this is a double definition of a function. Yes. Okay, guys. So now the question is that what if for some already 8 seconds should be very good time. It's a very good time. It may be unlikely that you need interrupts more than 8 seconds, maybe, but just let's assume for some reason I want to trigger interrupts more than 8 seconds or more than 64. Okay, so what I'm saying here, guys, I have a limit. the limit based on the numbers I have should be 8 or 64. For example, what if I'm going to use internal clock, but I want to do something every 80 seconds? So what can I do? You understand the question? So the question, I cannot trigger interrupts more than 8 seconds. I can't, okay, because this is the maximum, this is the limit. So now the question is that, what if I want to do something every more than that? For example, every 80 seconds, and I want to use internal clock. What can we do? Okay, very simple thing we can do. Okay, what can we do? For example, I'm going to make this one every 8 seconds. 8 seconds here. And then in the interrupt subroutine, I'm going to count. This is interrupt 1, interrupt 2, interrupt 3, interrupt 4. You got what I'm saying? So here, when it is interrupt 1, number 1, so here, actually, I'm going to make a variable, whatever the call of variable you are going to use, counter or whatever, counter. Here in the interrupt subroutine, every time I'm going to increment the counter. Okay, so I'm going to increment this interrupt number 1, interrupt number 2. Okay, and then I'm not going to do any action. Okay, however, when I come to interrupt number 10, that means it's already 80 seconds. Now I'm going to do some action. And then I'm going to reset the counter again. You understand what I'm saying? So what I'm saying is that the hardware is not going to allow me to trigger interrupts more than 8 seconds. That's the hardware. Okay, so what if I want to do something every 80 seconds? Okay, so all what you can do is that here in the end, I'm going to, every time here, I'm going to increment. So here, interrupt number 1, this should be 8 seconds. Interrupt number 2, so now it is 16. Interrupt number 3, now it is 24, and so on. Until when I come to interrupt number 10. At interrupt number 10, that means it is now 80 seconds. Now you can do, so here you can do whatever you want to do every 80 seconds. So here, what you have to do is that, number 1, you have to increment a variable. Number 2, you have to check if this variable, okay, less than 10. Why 10? Because I want to do something every 10 interrupts. Every interrupt is going to be 8 seconds. That means every 80 seconds. Is that okay? So if it is equal 10, so that 10, so now you can do something. If not, you are going to leave the interrupt subroutine. Is that okay? Any questions? Okay. So now I was explaining what if you want to do something every more than 8. You know what I'm saying? Anyway, again, what I'm going to do now, guys, is that here I'm going to start to explain how can you use the 7 segment. And now what I'm going to do is I'm going to go back to chapter 3 to explain how can you program it. And as you are going to see right now, you can use it by writing the code to the main program, or you can write the code in the system tech. Okay, as you will see right now. Okay, so I'm gonna show you both of them, similar to flashing. So here, when I did flashing, yeah. So here, when I did flashing here, I told you, if you look at this program, guys, you have a very similar program to this one in chapter 3, but I put the code in the main program. You got what I'm saying? That's what I told you. So you can do one task. It's your design. You can do whatever you want to do. I can design a task by putting it in the main program, or I can put it in a subroutine or an interrupt subroutine. You got what I'm saying? That's exactly what I did here. If I want to do flashing, so in chapter 3, I explain I can do it by writing a code to the main program. Here I'm explaining if you want to do flashing, you can write it in system text. The same thing I'm going to explain right now. I'm going to show you if you want to use the 7 segment. I'm going to show you can put it in the main program also in the system text. So now I'm gonna go back to chapter 3. Yeah. So let's see how. Again, as you see here, guys, we have 4 7 segments. So in every 7 segment, as you see here, every 7 segment is actually, it has 7 LEDs. 7 LEDs. Okay. So this actually, this is one, let me go here. Okay. So this segment is 1 LED. This segment is 1 LED. This segment is 1 LED. So every segment we have here is actually 1 LED. Is that okay? And now we can make any number by just turning on some segment and turning off some segments. You got what I'm saying? So again, it's so here, for example, if I want to display number 2, so this LED has to be on, this one 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 has to be, this one has to be off, and this one has to be off. By this way, I can make number 2. You understand? For sure, I'm going to explain how can we do that, but that's what you have to keep in mind. This is how the 7 segment is made. So the 7 segment we display, we have 7 LEDs. By the way, this dot also is another one. It's actually 8. So we have 8 LEDs, but I'm going to focus on the segments. So we have 7 LEDs. If you want to make a certain shape or a certain number, 0 or 2, 3, 4, 5, whatever, all what you have to do, you have to turn on some LEDs, you have to turn off some LEDs. Okay. So we have 2 types of 7 segment. One type is called common cathode. The other one is common anode. So what is the difference between them? Okay, so when you buy the 7 segment, you have to see if the 7 segment is common cathode or common anode. Okay, what is the difference between them? I'm going to tell you what is the difference is that in case of common cathode, as you see here in the figure, again, every segment here is 1 LED, as I told you. Every segment is 1 LED. So what happens is that they are going to connect, in case of common cathodes, they are going to connect all the cathodes together, and then it's going to give you one pin here. Okay. So if you buy this 7 segment, actually, so how many pins you can find? So actually, we are gonna have here 8 pins, including the dot for sure, because there's one for the dot here. Also, we have another pin here for the common cathode. Okay, so how can we use this one? Okay, the way, again, what happens, guys, internally, all the cathodes are connected together, and then are gonna give you an external pin here. Okay, so how can you use this one? The way you have to use it is, this pin that has the common cathode, you have to connect it to ground. Okay, so you have to connect this one to ground. And now, if you want to turn this segment on, all what you have to do, you have to put 5 volts on this pin. Is that okay? If you want to turn this segment on, so you have to put here you have to put 5 volts to turn it on. So as you see here, guys, you know, in case of if you want to turn an LED on, the anode, the voltage of anode has to be greater than the voltage of the cathode. Is that okay? So this is one 7 segment. We have another 7 segment, we call it common anode. So the way this one works is that, okay, again, guys, when you buy a 7 segment, we have 2 types. Okay, internally, either they connect all the anodes together, or they connect all the cathodes together. There's a small difference between how we use it. Small difference. Okay, as I'm going to explain right now. Okay, so if you want to use this one here, as I told you, so you have to connect the common cathode, you have to connect them to the ground, and if you want to turn any LED on, you have to put 5 volts. Makes sense? Okay. However, here is going to be different. Here, what you have to do here, guys, you have to connect this one to 5 volts. You have to connect this one to 5 volts, and if you want to turn any LED on, you have to connect to ground. So ground is going to turn it on. Why? Simply because if you put here 5 volts, this one is off. If you put 5 volts, why? Because to turn an LED on, the anode has to be greater than the cathode. Okay, so here I showed here, guys. So for example, this one here is a common anode. So we connect all the anode together, as you see here. So in this case, if I put here 0 volt in the common anode, if I put 0 volt, so it's actually disabled. What do you mean by disabled? That means if you put here 0 volt or you put 5 volt, they are off. Okay. In order to turn the LED on, the anode has to be greater than the cathode. Okay. However, if I put here 5 volt, okay. So if you put 0 volt here on one input, so actually you are going to turn it on. But if you put 5 volt, you actually is going to turn it off. Okay, guys. So let me tell you the conclusion. The conclusion is that the 7 segment we have here, okay, it's even written, if you can see it's written up here, it's common anode. So the 7 segment we have here, they are common anode. It's written here, okay? So how can we use it? Number one, the common anode has to be connected to 5 volt. You don't need to do that because this is already, it is done by the board. So the board already is gonna connect the anode internally, okay? So the anode is connected to 5 volt here, okay? And now, all what you have to do, if I wanna make any shape, if I wanna make any digit, in order to turn a segment on, you have to put 0 volt. If you wanna turn it off, you have to put 5 volt. This is the conclusion. Okay, guys? So again, if I wanna use this one, how I can use this one? Okay, very simple. The way I'm gonna use it is, number one, okay, so here you have here's the common anode. Okay, for the common anode, I'm gonna connect it to 5 volt. That's okay. And then we have here some pins for A, B, C, D, and so on. So I can connect it to the microcontroller. And very simple, if you wanna turn any segment on, you are gonna put 5 volt. If you wanna turn any segment off, you can put, sorry, the opposite. If you wanna turn it on, you have to put 0 volt. If you wanna turn it off, you have to put 5 volt. Is that okay? Okay. So however, we have here, okay. So now we have a problem here. What's the problem if you do it this way? Okay, so as you see here, guys, we have 4 7 segments. We have 4 7 segments. So the very naive way, if I want to use the 4 7 segment, the very naive way, how I can do it? Okay, I told you every 7 segment here, I can connect the anode to 5 volt. And now we have here, at least we have 7. If you are not going to use the dot, because the dot is actually another one, but you have here 7. And then the second one, we have 7. The third one, we have 7. The third one, we have 7. So I can connect them to the microcontroller. So this is a problem. The problem now, look, how many pins I need? Too many, right? So because I'm going to connect here 7, I'm going to connect here 7, 7, 7 this way, okay? So how many you need? It's going to be 7 times 4, okay, which is actually 28. The whole processor has, I think, 30 or 32 pins. For just that's too much. You understand the problem? So the problem now, guys, it's too much. We don't have enough pins to connect it this way. Is that okay? So what can we do? How can we reduce the number of pins? So actually, to reduce the number of pins, we're gonna do 2 things. We're gonna do 2 things. Number one, we're gonna use shift register. You remember just shift register we used before in the LCD, so we're gonna use another shift register here. Okay. The second thing is we're gonna do something we call time multiplexing. Time multiplexing. Okay, guys. Okay, what this means? I'm gonna tell you what this means, but listen to me first. Look here, guys. If I want to display here any number, for example, 7251. So actually, what this 7 you are gonna, if you do this connection, this 7 is gonna be displayed all the time. It's gonna be, if you put here 2, so it's gonna be displayed all the time. If you put 5, so you have to put here some zeros and ones to display 5, some zeros and ones to display 1. So all of them are displayed all the time. Is that okay? No, we can do better than that. Or that's what we call time multiplexing. So what do you mean by time multiplexing? What is the idea? I'm going to tell you what is the idea. And just also you should understand, again, we're going to do time multiplexing simply because I want to reduce the connections. Okay, we don't have enough pins. So let me explain what I mean by time multiplexing. It's shown here. Yeah, so the idea is that, guys, as you see here, I'm gonna turn on only one LED, 1 7 segment at a time. Okay, for example, as you see here, so I want to display 3802. I want to display 3802. Is that okay? So the way I'm gonna do it is, that's what we call time multiplexing. So number one, you should understand what I mean by time multiplexing. You should understand why you are going to do time multiplexing, okay? Let me explain first what we mean by time multiplexing. What I mean by time multiplexing is, I want to display 3802. Okay. So the way I'm gonna do it is, as you see here, I'm gonna turn this LED on. I'm gonna display 3, and the other ones are off. Then I'm gonna display here 8, and the other ones are off. Then I'm gonna display this one, I put 0, and the other ones are off. Okay. Then I'm gonna display 2 here, and the other ones are off. And then I'm gonna go back to here. If I do it very fast, if I do it fast enough, as you will see right now in the video, you are gonna see a very stable number. You got what I'm saying? It's the same idea of interrupts. As I told you, if you do it fast enough, so actually in reality, that's what we call time multiplexing. So this one at a certain time, for a small time slot, I'm gonna turn this one on, turn this one, turn this one, turn this one, and then I'm gonna go back to do it quickly. If I do it quickly enough, you will see in the video very stable number. However, if you don't do it fast, you are gonna see flicker. Flicker means you are gonna see some of them are turning on and off. Also, you are gonna see it in the video right now. Okay, guys. So again, so here, so how this can again? So number one, what is the idea of time multiplexing? It means I'm gonna turn only one LED on at a time. Okay, and then I'm gonna do it very fast so that you can see stable number. Okay, this is time multiplexing. Okay, so this is number. So why? Hopefully you understand what I mean by time multiplexing now. Okay, so the idea, why you do it? Why you complicate this way? Because the other option is too bad. What is the other option? The other option is that I'm gonna make here 3. I'm gonna keep it stable all the time. I'm gonna turn this one 8. I'm gonna keep this one 0, and this one is 2. Okay, but in order to make it this way, so actually we need too many pins from the microcontroller. So we need too many pins. Okay, so here, okay, so how this can reduce the number of pins? I'm gonna tell you how. Look here, guys. So the way you are gonna do it is actually you are gonna have seven pins for A, B, C until G. Okay, so these 7 pins are connected to all of them at the same time. So these 7 pins are connected to all of them at the same time. Is that okay? Also, I'm gonna use the common anode for enable or disable. So this one is gonna be, as you see here, for enable, disable. So all what I need right now, I need 7. Again, 7 or 8, because the 8 is the dot. Okay, anyway, so I'm gonna here say 7. So I need 7 plus I need 4 pins for enable or disable, as you see here. So the idea is that, look here, guys. Here I'm gonna put 1s and 0s here to make number 3. Okay, so I'm gonna turn this one on and off to make number 3. Here I'm gonna put here 5 volt here. I have to make sure 0 volt here. As I said before, when you put 0 volt, actually are gonna turn this one off, and you turn this one on. Okay, why? This is electronics. This is what electronics told us. So I'm gonna go back to show you. So here, as you see here, look, guys, if you put here 0 volt, you are gonna turn it off, regardless of whatever here. Because if I put here 0 volt, so this one is off. If you put 5 volt, also it is off. To turn an LED on, the anode has to be greater. So what I'm saying is that if you put 0 volt in the common cathode, so this LED is off. Is that okay? However, if you put 5 volt, so you actually here, you turn this LED on. Okay, sorry, you turn this 7 segment on. Now, 0 is gonna turn on, 5 volt is gonna turn it off. So the idea now, guys, is that number one, I need 7 pins to connect to all of them. This is the main idea. So now this I have here. So this one is connected to all of them. So whatever the number I want to display, so here I'm gonna turn on and off. I'm gonna turn on and off some 7 segment, and then now when I disable this one, so this one is gonna come to here, and the other ones are off. And now if I want to display number 8, so I have to put here 1s and 0s for number 8, and this time I have to turn this one, so that again this one is connected to all of them. Makes sense? However, this one is already disabled, so I'm gonna turn on only one at a time. You understand the idea? Any questions? So again, here, these seven pins are connected to all of them. Then I'm gonna, using the common cathode, I'm gonna control which one is gonna display the number here. So in the very beginning, I have to put here, I have to put 1 and 0 here that can display number 3, and I have to enable this one. Okay, this number 1. The code has to do that. Then I have to put here 1s and 0s to display number 8, and also I have to enable this one, and then 0, and then enable this one, and then I have to put here whatever equivalent, and then you have to 2, and you have to enable this one, and you have to repeat it. Any questions? Again, number 1, guys, you should understand what is the meaning of time multiplexing. You should understand, in order to get a very stable number, as you will see in the video, okay, there should be, you have to do it fast enough. If you do it slow, you will see flicker, okay? Also, you should understand why you are doing it, in order to save the number of pins required from the processor. Is that okay? How you did? Because I can actually do this one by 7. So here I need 7 pins, also plus 4. So now total I need 11. Okay, because I need 4 here. 4 plus 7, I need 11. If you don't use if you don't use time multiplexing, how many do you need? Okay, so I need, so I'm not going to use this one as enabled, so I'm going to enable all of them all the time. So actually I need 7 times 4, which is 28. So by using time multiplexing, I was able to reduce the number of pins from 28 to 11. Make sense? Okay, guys? Okay? Okay. For some processors, listen to me, for some processors, 11 are okay. So especially if you have a big, if I have a big microcontroller has too many pins, like for example, you have 100 pins or so. So maybe 11 are okay, okay? So you can just connect it directly to the microcontroller. Sometimes we do that, okay? Here, because this is a small processor, even 11, I was able to reduce the number of pins from 28 to 11. Now I want to reduce it more from 11. Okay, so I'm gonna reduce right now. It is from 11 to 3, only 3 pins. How can you do that? By using shift register. So here I'm gonna use shift register, and as similar to what we did before, we need only 3 pins. So the output of the shift register, we need 7. We need 7 here. This 7 is going to be connected to everybody. We need 4. These 4 are going to be connected to here. You understand what I'm saying? And this is how they connected this is how the 7 segments are connected here in this port. It's very interesting. By this way, so again, I'm going to use, in order to reduce the number of pins needed to connect the 7 segment, I'm going to use 2 techniques. Number 1, time multiplexing. Time multiplexing can reduce the number of pins from 28 to 11, right? Number 2, I can reduce it from 11 to 3. Okay. So how you made it? I'm going to tell you how I made it. Okay. Again, all you need to understand, guys, is that we have here. I'm not going to connect the mic again. In some processors, we do that. In some processor, we connect directly. Okay, and we need 11 pins. Yeah, some processor, yes, we can do this way. Here, we're not going to do this way. So microcontroller, I need only 3 from the microcontroller to connect it to the shift register. And the shift register is going to give me 11, okay? It's going to give me 7 for 8, A, B, C, D until G. And these 7 are connected to everybody, okay? Also, we need 4 for enable or disable. So this one is going to come here, this one is going to come here, this one is going to come here, and this one will come here. And then I can do time multiplexing. Any questions? Okay. So now, yeah, this is how they made it, guys. So now, if you use only, by the way, you know, on the course website, you have the diagram. So yeah, so if you go to the course website, you will see you have the diagram for the board. Yeah, you can see how they made it. So you can see that it's explaining how it was connected. You remember, I also used the shift register before, but here, unlike the LCD, in case of LCD, I needed only one shift register, okay? Because every shift register, this is the number of the shift register. This one give you up to eight pins, okay? So in the case, let me push, just I want you to understand it. Yeah, here, if you come here, yeah, look here, guys. I want you to understand again, this is how the people who designed this board, this is how they made it, as I told you, okay? So if you see here, guys, this is for, we used to only, this is the number of shift register. I used to only one chip, because every chip has eight pins. I used to only one chip for the LCD, because in case of LCD, how many I needed? I needed 1, 2, I think all that I needed, as I explained before, 1, 2, 3, 4, and 2. So I needed only 6. This shift register can give you up to 8. You understand what I'm saying? So 1 is enough. However, now 1 is not enough. Why? Because I need 8 for the ABCD and the dot. Also, I need 4. I need 4 more for the enable of for the common cathode. So the way it was made, as you see here in this part here, guys. So so now I'm going to use 2 chips, not only 1. I'm going to use shift register, but I'm going to use two of them, because this one give me 8. This one can give me another 8. So every chip here is going to give you 8 flip-flops. Okay. So, and again, in order to connect them together, actually, so we have here, I have to connect this is how they made it. You have to connect this one to this one, okay? By doing that, you are going to connect the last flip-flop with the first flip-flop here. So every chip is going to be 8. Once I make the connection this way, so it's this 2 chip is going to be like 1 chip with 16 flip-flops. You got what I'm saying? So if I go here to, again, if this is too difficult, it's not too difficult. If just you have the data sheet of this one. So here, that's what I'm explaining. Look here, guys. So this is only 1 chip. This is 1 chip. So if I get the output, if I get this one here, and if this is output from 1 chip, this is the serial data output. So if I connect it as an input for the second one, so now it's going to be like you have 8 flip-flops connected to 8 flip-flops. So I'm going to use 2 chips, but the way I'm going to use it, it's like 1 chip. It's like 1 chip, and this chip has 16 flip-flops. Is that okay? So, and again, if you go, this is how the people who made the board made it. So as you see here, guys, we need 2, and you should understand why we need 2. Okay, in this one we have 8, as you see here. Out of this 8, we need only 4, as you see here, for enable. So this will be the common cathode. Okay, so any one of these, if I make it 1 or 5 volt, you actually enable. So as you see here, so let me go here to show you how it is connected. Yeah, here, look here. How this, yeah. So actually, as you see here, guys, as I told you guys, every chip, all of them are going to be connected to ABCD. Okay, so we're going to call them QA, QB. So QA means this one is connected to segment A, segment B, segment C. So this segment from A, B, C, D, G, and H. H here is actually the dot. Okay, anyway, so we have 8 of them here. These 8 are connected to all of them. But as I told you, if all of them are enabled, so we're going to see something like, if I display 7, you are going to say 7, 7, 7, 7, because all of them are going to display whatever number you put here, if all of them are enabled. But actually, the way, so it's that, you understand what I'm saying? So here you have A, B, C, D, E is connected to all of them. But I'm going to only enable 1 of them to show this number only in 1 of them. How can you do that? I told you, as you see here, guys, we have 4 here. Digit 0, digit 1, digit 2, digit 3. So the digits that you are going to make it 5 volt, you are going to turn it on because this common node. Okay. So the way it is connected, so these 4 are connected to the first, are connected here. Okay. And these 8 are connected here. Okay, guys. And again, all what I need from the microcontroller is three, as I told you. So here we have MOSI. Okay. So this is serial when you send the data serial. Number 2, you need clock for this one. So every time you put one, 0 or 1, you need to generate one clock to insert this bit. After you finish, you need to latch. So you need one more for the latch. So as you see here, guys, here for this one, I'm gonna connect the shift here with the shift here. They are gonna be connected together. So that when I shift a pin, this one are gonna shift. This one also is gonna shift as well. So they are gonna be connected as one big shifter, just 16 bit. That's why I have to connect this shift clock with the shift clock. They're gonna be connected together. At any time when I shift, this one is gonna shift. This one is gonna shift. Also, here we have when you latch, when you do the latch, as I explained to you before, also this one is connected to this. Okay, so it's too much details, but let me give you the conclusion. The conclusion is, okay, number one, we have 4/7 segment. This in order to connect the 4/7 segment, I need 28 pins. That's too much for sure. Okay, even if you have a big processor, I can't use 28 pins just for the 7 segment. Okay, to solve this problem, we're going to use the idea of time multiplexing. Time multiplexing can reduce the number of pins from 28 to only 11. Okay, so or you can say 12 in case you use the dot, because most of the time we don't use this dot. But if you want to connect it, we need 8 for ABC and the dot. This 8 should include 7 pins for the 7 segment and 1 for the dot. Also, we need 1 for the enable. Okay, so if you use time multiplexing, you need 8 plus 4 enables. Okay, so total. So we can, because of time multiplexing, we can reduce the number of pins from 28 to 12. Okay, and now I can even reduce it more from 12 to only 3 by using, because I'm not. If I cancel this part, I just connect it directly here. I need 4 pins here. I'm gonna connect it directly to the microcontroller. So I need 8 here and I need 4 here. Okay. However, if I'm not gonna do it because I want to even reduce it more. So now I'm going to reduce it. Time multiplexing reduced it from 28 to 12 because of the shift register I'm going to put here. I'm going to reduce it from 12 to only 3. Okay, and because I'm going to connect these ones to here, and then all what I need from the processor only 3. So I'm going to make very quick, because I already explained it before, but I'm going to make very quick revision on how this time multiplexing works. So again, this one is connected to the microcontroller. This one is connected to the microcontroller. If I put here 1 and then I generate a pulse this way, so actually this one is going to come here. It's going to be stored here. Okay. Then if I wanna input 0, so I have to put 0 here, and then I'm going to do shift this way, and so on. If I'm going to put 1 here and generate. So every time I have to generate this one, I have to generate this one. I have to, and so on. So by doing this one, I put 8 bits here. Okay, guys. However, these 8 bits are not going to be shown on the output until you latch. You do the latch, which is here. So once I generate here, sorry, this is a latch. Once I generate a signal this way here, so whatever here is going to go to the output. Okay, guys. This example is only for 8, but actually what should happen, we have another one connected here. So total we should have 6. Okay, guys. Again, this is exactly what I did before. And again, don't worry. All what we are gonna do, for sure, there is always trade-off. Okay, guys. Yes, we reduced the number of pins, but now it became, you need, number one, you need hardware. Okay, hardware here. So you need 2 of these chips to connect them. Number 2 is going to be slower. We are going to make it slower. Okay, guys. Same thing for time multiplexing, because you need the software to do some time multiplexing. Okay. Yes, that's true. So what I did here, guys, similar to what I did before, I just did it here. Look here, guys. I created a function. This function is called write 7 segment, write to the shift register of the 7 segment. if you go to the LCD, you will find we had exactly same function, but it was not shift register, it was LCD. Okay, guys, okay, and we used a different pins. Anyway, so we have this function. In this function, you have to send 2 bytes, as you see here. 1 byte, I'm gonna call it enable, and then another byte, I'm gonna call it this is the digit you want to display. So here, so 1 byte, this is the enable byte, is gonna be I have to put it here, and then the digit I'm gonna put it here. Is that okay? So now I have a function. This function I'm gonna send 2 bytes. Okay, and then what the function has to do is it has to do shift, similar to what I explained, so that after the function is done, the 2 bytes you have are gonna put them. You understand what I'm saying? Okay. So here, yeah. So as you see here, that's exactly what I did. So what I did here, guys, as you see, I made 2 for loops, similar to what we did before. I made 2 for loops. Okay. So here in every iteration, we're gonna shift 1 bit by bit. Okay. So I'm gonna start, which I have to start with this one because every time you shift. So here, if I come here, guys, so I have to start with this one because actually the first bit you entered is this one, because every time you shift, so you have to enter this one first. So this is the first one has to come here, and then after I shift it here, it's gonna come to here. You understand what I'm saying? So yes, so I'm gonna start with this one. After the first 4, they are gonna become here. After the second 4, they are gonna be shifted to here. Anyway, so yeah, that's exactly what I did here. So as you see here, guys, what I did, similar to what I did before, I'm gonna use a mask here this way in order. So I'm gonna start here. This one is just a byte. So I'm gonna put here 1 0 0 because I want to check this bit. If this bit is 0, so I'm gonna insert a 0. If this bit is 1, I'm gonna insert 1, and so on. So as you see here, guys, that's exactly what I did. So here I'm gonna check this bit. I'm gonna check the last bit, as you see here. If this last bit is 0, okay. So all what I'm gonna do here, I'm gonna put 0. Otherwise, I'm gonna put 1 here. Yeah, here I'm gonna put 0 or 1. So you have to put something here, as I told you before, and then you have to generate here a pulse this way in order to insert. That's exactly what I did. So as you see here, in every iteration, number 1, I have to put 0 or 1 based on what. So here, as you see here, guys, so here I'm gonna check this bit. If this bit is 0, I'm gonna put 0. If this one is 1, I'm gonna put 1, and then I have to generate the pulse here, okay, in order to insert. Because every time I have to check a different bit, as you see here, guys, my mask start with 1 0 0 0, as you see here, and in every iteration I'm gonna move the 1. So in the first iteration, because I want to check this bit here, the 1 is here. In the second iteration, the 1 is here. In next iteration, the 1 is here, and so on. So after 8 iteration, you can see this number. It's already, you put it here. Okay, guys. So now you shifted 8. We need to shift another 8. That's exactly what I did. So after this 4, I'm gonna make another 4 in order to shift this 8. Okay, guys. And then when I am done, I have to latch. I have to make a signal for the latch. Okay, guys. So number 1, you should understand why we use shift register. Okay. You should understand how I programmed it, how we use it. Okay. And now the conclusion is that this is conclusion. The conclusion is that you have a function. Okay. In this function, you have a function. This function, you have to send me the enable, and you have to send me what number you want to display. You got what I'm saying? Just send it to the function. The function is gonna do it. Okay. So here in the enable, look here, guys. If the enable is actually 1, so it's gonna be 1 0 0 0. In this case, if it is 1, so actually you are gonna enable digit 1, the first digit. But if it is actually 2, so I'm gonna enable the second. So it has to be 1 2, or it can be 4, right? Or it can be 8. So yeah, that's how it is. So because we only use the first 4 bits, so the first 4 bits should be 1 0 0 0, or if you want to enable this one, or it has to be 1 here 0 0 0, or it has to be 1 0 0, and so on, 1 0 0. Okay. Here, here you have to send what we call it 7-segment code. 7-segment code. What do you mean by 7-segment code? I'm going to tell you what I mean. So if I come here, yeah, that's what we call 7-segment code. What do you mean by code? I'm going to tell you. As I explained here, guys, in order to turn on any segment, you have to put 0. So 0 means on, 5 means off. Okay. So let's see here. If I want to display number 0. So here, this is segment A, segment B, segment C, D. So every one of them is connected to one pin from the shift register, A, B, C, D. Okay. So look here, guys. If I want to display number 0, so this one has to be on. On means 0. So I have to output 0 to this pin, right? So I have to output 0, 0. So all of them are zeros except G has to be 1. So this is the code. So that means if I want to display 0, this is the code. I have to send this code, C0. You understand what I'm saying? Because this code is going to turn all the segment on except G. Okay, guys? So this is the code you have to send here. Because this is A, B, C, D, and so on. Okay. So for example, as you same thing for other numbers. For example, if I want to display number 1, okay. So actually in number 1, C and D, so I want to turn these two on and everyone else is off. So as you see here, 0, 0, and everyone else is off. Is that okay? Same thing for all of them. For example, number 9. Number 9, I'm going to turn all of them except E. So all of them are zeros, except E is 1. You understand what I'm saying? So in case of 8, so I have to turn all of them on. Is that okay? So actually here, as you see, always we have H, by the way. Okay, but H, for H, I just put 1, 1, 1 for H. Because one is because I want to turn H off for all of them. You understand what I'm saying? So that's why you can see always we have 1 at the end here. Any question, guys? Easy, right? So you should understand if you want to display a number, you have to put this code, the code of this number on A, B, C, D, and so on. Is that okay? Any questions? So let me tell you the conclusion. So the conclusion here, guys, for example, if I want to display number 7 on digit number 2, what should I do? Okay, number 1, here you have to send the code of 7. You have to put the code of 7 here. Okay. Number 2, you have to make sure this digit is 0, disabled, and this one is enabled. By this way, you can see 7 here. You got what I'm saying? So if I wanna use this one, okay, simple. You can put here 1, 0, 0 to make sure only this one is enabled and the other one are disabled. You can see 7 here. Is that okay, guys? Any questions? Okay, I'm gonna make it even more easier than that. Look how I'm gonna make it easier than that. Look, I'm gonna create a function, and this function just to give me 2 things. Give me what number you want to display, 0 or 2 or 7. Give me the number you want to display. Also, give me which digit you want to use for 0 or 1 or 2 or 3 and so on. Or I think it's not 0, 1, 2, 3, 4. Just to give me the number, okay? And then I'm gonna hide all the details from you. Don't worry about how I'm gonna do it. Don't worry about what code I'm gonna use. That's exactly what I will make it even more easier. So I created a function here. Remember, the function I'm going to use right now, it has to use this one, the shift register here, okay? So this is a function I created. This function is called write to 7 segment, write to 7 segment. In this function, you just tell me, you have to send me 2 things. Send me a number, okay? This number can be number from 0 to 9. The number you want to display. Also, you have to send me here, actually number 0 or 1 or 2 or 3. You have to send me which digit you want to use, okay? And internally, as you see here in this function, guys, I created 2 arrays actually. I created one array to convert the number you are going to give me to the code I have to send to the shift register, okay? So here, this is the code for 0. So if you send me 0, so this is the code I have to send to the shift register. if you give me number 1, so this is the code I have to send, as you see here. So this is a function I just explained for the shift register. It has two bytes, 1 byte for enable and 1 byte for the digit you are going to display. All what I'm going to do, guys, this is the digit you are going to send to me. So I'm going to get this digit, and then I'm going to go to this array. So if you send me, as you see here, so if you send me number 0, so I'm going to send this one to the shift register. If you give me number 8, I'm going to get this one. If you send me number 9, so I'm going to send this one. Is that okay? Also for the enable, I created another function for the enable here. Okay, so if you send me here for enable, so if you send me here, so if you send me here, this is for digit. I think this is for digit 0. Sorry, this is element number 0. I created it in somehow different way. So this element is 0. This is element 1, element 2. Okay, element 3, element 4. So actually, element 4 is going to be 1 0 0 0. So it's going to this digit. I'm going to call this first one digit. This digit. I'm going to if you go here, I'm going to I think here. Look here, guys. So this one here, this one is 4. Okay, so if you give me 1, if you tell me this one, so we have 4 7 segments. This one I'm going to call it number 4, or this is how it is called actually. Yeah, this is how they call it here. So they call it. This is display number. This is display number. I think. This is display number 1, display number 2, number 3, number 4. Is that okay? So if you wanna use this one, so you have to send the number 4. This is the number you have to use in the function. So when I make this function, I try to make this function compatible with what you see here. So if you want to use segment number 4, just send me number 4. If you want to use this one, it's written under this one number 3, display number 3, and so on. Is that okay? And that's exactly what I did. So look what I did here. Yeah. Sorry. So see how I made this function, guys? I made it so that when you send me 4, it's very simple. So all what I did is, if you send me here, so here in the digit, you have to send me to this function. You have to send me either here 1 or 2 or 3 and 4, and you have to keep in mind based on whatever written here. So 4 means the first one here on the right. Yeah, they are 4 this one. This is number 4, number 3, number 2, number 1. Is that okay? And the way I made it, as you see here, guys, in this function, is that if you send me 4, so I'm going to take this one. And this, I'm going to send it here in the enable. So that is going to be 1 0 0 to turn this one on. Okay. If you send me number 3, I'm going to take this one. If you send me number 2, I'm going to take this one. If you send me number 2, I'm going to take this one. Is that okay, guys? Anyway. So in order to make everything very simple, very, very simple, all what I did, guys, I created this function here. You are going to use this function all the time. This function actually is gonna call the shift register function. Okay. All what you have to do is that you have to send here two arguments. In the first argument here, you have to tell me which display you want to use. So you have to send me 4. I told you the first one is 4, 3, 2, 1. So you have to send me 4 or 3 or 2 or 1. Okay. Also here, you have to just to give me number. If I want to display 7 or I want to display 9, whatever. And then I will do the conversion internally here. Okay. Any questions? Okay. Now I'm going to show how we are going to use it. First of all, also, we need to do initialization. Similar to what we did before, we need to do initialization. But here, what kind of initialization you are going to do? Very simple. Because we are going to use 3 pins, we're going to use 3 pins. So I have to configure these 3 pins output. That's it. That's it. So here, I'm going to use this pin here. This is PB5. I'm going to use this one here. This is a PB3. I'm going to use this one here. This is BA3, BA7. That's it. And this is also the same. So this actually connected to this one. And this one is actually connected to this one. So all what I'm going to do in the initialization, I'm going to configure these 3 pins as output. Okay. So where is, I think maybe I didn't put it here, but this is if you, so that's why I created a function to do the initialization. It looks like I didn't put it here, but yeah, you can find in on the codes I posted online. Yeah, so here, yeah, so now we have this function initialization for 7 segment, guys. I didn't put the code here because it's just very easy. You can find it on the site. So let me tell you the conclusion. How can you use the 7 segment? Tell me that I'm going to tell you the conclusion. Number 1, you have to call this function. So number 1, if you want to use the 7 segment, the first thing you have to do is that number 1, you have to use this function to do initialization. This number 1. Is that okay, guys? Number 2, you have to make sure your program has 2 functions. This function, this is the one you are going to use all the time, right to the 7 segment. Also, you have to put this function, okay, which this one is going to write to the shift register. You are not going to use this one directly, but actually this function is needed here. So actually, you have to make sure your program has 3 functions. Is that okay? However, what you are going to use only 2. You are going to use this one, and then that's it. So you just this one for initialization. Number 2, every time you want to display something, very simple. Just to call this function, tell me which display you want to use, 1 or 2 or 3 or 4. Tell me which number you want to display, 7 or 8 or 9, whatever. That's it. Okay, so now I'm going to show a couple of programs. The first program here, write a program to make 1 7 segment display, like count from 0 to 9, okay, and then repeat. So, and then the display should change every 1 second. So what I wanna do here in this program, I wanna use only one display. I wanna display 0 for 1 second, and then 1, 2, 3, 4, until 9. After 9 should come 0 again, like a count. Okay. I can show you have already this program here, guys. Also, you have the video. So let me show you the video to understand better. Then I'm going to choose the code. The code is very simple. Why is the code is very simple? And this is the beauty, or this is the beauty of using functions. The code is very simple because the complexity is hidden in functions. Just if you want to do something, put the function. And the function is everything is hidden inside this function. Okay. Anyway, I should explain everything for sure. And I already did. I already explained every details, right? But if you want to use, you can just call a function. That's it. Even I explained how I need this function. Just think. By the way, maybe in some of your project you want to do something different from what you did. For example, what I explained here is how can you display number from 0 to 9? By the way, you know, sometimes we use the 7 segment here to display some letters, very few letters, like letter H, letter L, letter O. You know what I'm saying? Sometimes you do that. So still you can do it, but not all the letters for sure. So let me show you. This is very simple program, very interesting program. Yeah, counting 1 display. Look here, guys. Can you see? So for some reason, I decided to use this display. You can use any one of them. So you can see here it is 0 to 1, 2. I'm updating it every 1 second. Only one. I'm using only one display, updating every 1 second. After 9, it should come to 0 again. Okay. How can you do that? This is a program is here. Very simple program. Very simple. Look here. Number 1, you have to call this one time for initialization. Yeah. And you already know why I have to do it, right? So this is only 1 time. Okay, that's okay. And now all what I have to do, as you see here, guys, very simple. Just to call this function, give me which display you want to use, give me the number you want me to display. So what I did here, as you see, I made for loop. This one should loop. This for loop should loop 10 times from 0 until 9. So as you see here, guys, In the first iteration, I'm gonna display 0 on display. I'm gonna display number 0 on display number 2. Then I'm gonna wait 1 second, and then I'm gonna display 1. Wait 1 second. I'm gonna display 2. Wait 1 second, and so on. Any questions? Very simple, right? It's very simple because the complexity already inside this function. Okay? But you have to make sure if you put this way, your program is not going to work. Why? Because you have to make sure you put the other function with the shift register, because the shift register function is used here. Okay? You already have this program. Okay? Any questions? Yes, sure.
What's that function do when you send it value that's out of range?
This one?
Yeah, out of the 0 to 9 range.
Sorry, see the question again.
So like if your for loop went further, it went to 11 or 12.
Okay, that's a good question. Let's see what this function is gonna do. Okay, so the way I made this function, whatever, for sure, number one, I don't check for error here. Okay, so I don't check for error. I'm expecting here, you have to send me here 1, 2, or until 4. Here you have to send it to me something between from 0 to 9. That's what I'm expecting. I didn't check for error here. Okay, I'm assuming you are going to send to me in this range. Okay, let's see. For example, here instead of 4, you are going to send 6. For example, that's your question, right? So what's going to happen? You are going to try to read whatever you send here. Actually, I'm going to get this code from here, right? So if you give me number 6, so you are going to get error. Why? Because this array does not have number 6. You got what I'm saying? This array, it should be, if it is 1, that's what I want to use. If it is 2, 3, 4, that's what I'm going to use all the time. If you give me something else, you should receive error because you have a function, and this function actually you don't have it has to be until 4. You give me 6. You understand what I'm saying? Again, that's how I designed this one. I'm assuming you are going to send it as the right one. Any questions? Okay, now let's go to the idea of time multiplexing. Okay, how can you do it? Okay, if you want to, so for example, as you see here in this example, guys, I want to display this number 3, 4, 5, 6. Okay, if I want to display something like that, how can you do it? So as you see here, guys, these are the 4 digits I want to display 3, 4, 5, 6. I want to display this 4 digit. How can we do it? Okay, very simple. Very simple. As I told you, all what I have to do, guys, number one, I have to display this one on display number 4. Okay, so as you see here, look how I made it, guys. So I'm gonna call this function. I'm gonna say in display number 1. Remember, number 1 is here. That's how they call it here. Okay, so yeah, so this is 1, 2, 3, 4. That's how they name it here. Okay, anyway, so here for number 1, I need to display number 3. So here put 3, and the other ones are off because this function can enable only one at a time. So here I'm gonna number 3. I'm gonna display it on 1. Is that okay? And then after a very short delay, okay, or very short time, so I'm gonna say after that you have to put 2 here. So here, yeah. So the first one here is gonna put 3, and then these ones are off. Is that okay? And then this one here, as you see, is gonna put here 2. As you see, look here. I'm gonna change the display. So I'm gonna put 2, and these ones are off. Is that okay? And then this one here actually is gonna put number 5. Sorry, this is gonna put 4. I'm sorry, because yeah, 4 here, digit 3. So this one is gonna put here 5, and these ones are off. Is that okay? This one here is gonna put here number 6, and these ones are off. And then because of the infinite loop here, you are gonna keep doing it. You can see what I did? Yeah, it's gonna be 1 digit in display number 1, 1 digit in display number 2, 1 digit in display number 3, 1 digit in display number 4, and you have to do it fast. In while loop. That's what we call time multiplexing. Any questions? If you do this way, you are going to see a very stable number. You are not going to see that some of them are on and off. Okay. Look at the trick here. Actually, listen to me. That's a very important thing. Actually, after you run the program, you can have one of 3 things. After you run this program, you can have a very stable number. Okay, I will be happy. Very stable number. I'm very happy if I can get something like that. Also, you can see flicker. I'm going to show you the video flicker right now. Okay. So flicker means you can see on off. Some of them are on. It's not a stable number. Okay. So what if you get flicker or there is a flicker, what it means? It means that there is a big delay. There is a big delay here between these ones, a big delay. That's why you can see flicker. Okay. The other thing, it can be dim. Can be dim. Dim means, if it is dim means that means the delay you have here, it's a very short delay. Very short delay. It can be dim. So what? Why it can be dim if the delay is too short? I'm gonna tell you why. What happened is that, you know, guys, this is the brightness for an LED, and this is the time. In order to get the max, you have to tell the LED. You remember, this one is just an LEDs. You got what I'm saying? If you just turn an LED on for a very short time, and then you turn it off, okay? So the brightness may not reach to the maximum brightness. That's why it can be dim. You understand what I'm saying? So let me tell you the conclusion. The conclusion here, guys, in time multiplexing, there is a time delay between the time. If this delay is long, you can see flicker. So if you see flicker, that means you have a long delay. If it is dim, that means the delay here is too short because you didn't keep the voltage. The 5 volt, you didn't keep it for enough time. That's why the LED didn't reach to the maximum brightness. Okay? However, here when I did it here in this board, I actually when I put no delay, there was no dim. It was not dim. You know what? So usually for other processors, if you don't have the shifter register and you connect it directly, if you do this way, it should be dim. Why I'm explaining it this way? Because if you do it in your capacitor, you may not use a shifter register. Okay, so if you have a bigger processor, usually we don't need shifter register. You can just connect it directly. You know what I'm saying? So in this case, you have to make a delay here. So, but when I did it here, I didn't need to make a delay. When I canceled the delay, it was not dim. I expected to be dim, okay, but it was not dim. Okay, why? Because actually, the shifter register itself is going to make a delay. You got what I'm saying? So when I put the voltage, I'm not going to change it right away because there is shift. So there's already a delay in the shifter register. Okay, guys. So let me show you the video. So let me show you the video. But in general, that's what I'm saying. I'm explaining it just in case if you connect it directly in your capacitor or in the future without the shifter register, we can have one of 3 things. A stable number, for sure, that's what I'm looking for, or you can see flicker. So if you find the flicker, that means sometime here you have a long delay here, or it can be dim. In case of dim, that means you have a very short delay. You have to increase the delay. You have to keep the voltage for some time. You cannot just put voltage, remove the voltage. Put voltage, you cannot do that, okay? Because the LED needs some time to reach to the maximum brightness. Again, I didn't have this problem here. That's why I tried it with 5 volt, with 5 millisecond delay. It was okay. When even I canceled it, it was also okay because already the shift register is going to make some delay. Anyway, so let me show you the video here. Yeah. So look here, guys. Let me go back. Let me see what I did here. Yeah. So here I make the delay 0. So there was no delay. Okay, as I told you. Look, it's very stable number. You cannot see any flicker. 9026. It was not even dim. It was okay to me. Okay. Look what I'm. Okay. What happens if I put here more? If I make the delay bigger? For example, here I made it 2 milliseconds, I guess. 2 milliseconds, I think it was okay. Let me see what's going to happen. I was just playing to see what happens is going to when you put a delay here, okay? Yeah, still it's okay. Maybe brightness is going to be better now, but it's still okay because okay? I think now I'm going to increase the delay more. You will see something now if I increase the delay more. I made it here 100, for example. So here, this is the time between each each digit. So I'm gonna keep it for 100 milliseconds, 100 milliseconds. Now you can see, you will start to see flicker. Okay. Yeah, I think it's very, very obvious now. You can see the flicker. You can see flicker. Okay. Anyway, guys, so now I'm done, but I'm gonna just tell you something quickly because that's what I'm gonna do next time. Okay, guys. So now, as you see here, what I did, I just did the time multiplexing inside the main program. Inside the main program, I told you I can do the same thing using the timer, using the timer. So that's what I'm going to teach next time. I'm going to move this. I'm going to move the time multiplexing. I'm going to move it to the timer. Okay, why? Because as I told you before, the timer in the timer here actually, just quickly, the timer is going to do periodic interrupts. Okay, periodic interrupts. One interrupt, one interrupt, one interrupt, and so on. Okay, so this is what the timer is going to do. So what the way I'm going to do it, guys? Listen to me. In the first interrupt, I'm going to do this one. In the second interrupt, I'm going to do this one. In the next interrupt, I'm going to do this one. In next interrupt, I'm going to do this one, and then I have to repeat again. You got the idea? So I need to know. I need to count this interrupt number 1, interrupt number 2, interrupt number 3, interrupt number 4. After 4, I'm going to go to interrupt number 1. So it's like a counter. I have to should have a variable. This guy, if it's interrupt number 1, I'm going to do this one. Interrupt number 2, I'm going to do this one. Interrupt number 3, I'm going to do this. Interrupt number 4, I'm going to do this one, and then repeat again. You got what I'm saying? Now. If the time out, if you see flicker, very important what I'm going to say right now. Look here, guys. So now the time this is the time out here is actually the time between each two, right? If you see flicker, what it means? It means you have to reduce the time out of your timer because you wait too much. The time from here to it is too much time. That's why you cannot see you cannot see a stable number. You got what I'm saying? So what I'm saying, if you see flicker, it means it's a time out of your timer. So that means you interrupt every long time. That's why it's not a stable number. You have to reduce the time. Okay, guys, any question? And also in the future, you don't have this problem here because we shift the register. The shift register is going to make a delay. But in the future, if you connect it directly and you see the 7 segments are dim, what it means? That means it means the delay is too short. You need to increase the time out of the interrupt. So that you can have a more you can have like better brightness. Any questions? Okay. See you next time.